an open box of maximum possible volume. So you have here they're saying maximum possible volume. So main equation seems to be volume from a square piece of tin. So if I draw a sketch, so square piece of tin, right? Square piece of tin of side A. So you have side A is to be made by cutting equal square out of the corner. So equal square, so like you need to cut square from the corner. So this four squares that is cut off should be of same length, and it's not given how much length of square, square should I cut. So that's why you put x length, which means here x length I'm cutting off. Okay, so which means this thin portion here, squares from the corners are being cut off so that you can make a box. Now if I fold up this, it will form a box, right? They are asking you to show that length of a side of square cut. So the length of a side of square cut out is a over 6. So the length I have cut out is x here, so x should be equal to a over 6. So you need to prove. So this is to prove here. So if I have to prove, so since my main equation is volume, so volume of this box would be length times breadth times height. And since it is a square, so you notice here the base is a square shape, right? Square shape. So that is why length and breadth will be equal, right? So now since from this end to here is x, and you have another here which is also x, the small portion that we get would be, okay, since we have also the whole length from here to here is a, so the small portion that I have, the small portion that I have here would be a minus 2x, a minus 2x, because you need to cut off these two sides, right? So it says, so we already got our length. So our length of the box, the base of the box is a minus 2x. Again we have the breadth would be also same, a minus 2x, and you have the height which is x. So this is our volume. So we got the main equation here. If I further simplify by multiplying here, opening up the bracket, I will get, open the bracket, a square minus 4ax plus 4x square. Then further opening will be getting a square x minus 4a x square plus 4x cube. So this is the main equation. Now differentiate once, so you are getting a square minus 8a x plus, so here if I go in the long method, v dash means a square is considered as constant, so you differentiate the variable only. 4a is constant, so you differentiate the variable only, and similarly here as well. So you have v dash is equal to a square minus 2 will come in front, so 8ax plus 12x square. So this is a dash. So now we need to bring a dash equals to 0, which implies that 12x square minus 8ax plus a square equals to 0. So if I compare this, So basically what we know is, for a quadratic equation a square plus bx plus c equals to 0, your x is equal to negative b plus or minus square root of b square minus 4ac over 2a. If I compare this with the equation 12x square minus 8ax plus a square equals to 0, I find out that x square is a, then you have your b is 8 negative 8a, and your c here is a square. So then x will be equal to negative here, so b value is negative 8a, then plus or minus square root of, so negative 8a whole square minus 4 times, okay, so let me write this one out here. So you have x equals to negative is there, so a negative 8a plus or minus square root of negative 8a whole square minus 4 times a times c divided by 2a, 12. So x is equals to positive 8a plus or minus square root of, give square to all the three here, so positive 64a square minus 42 is 48a square whole divided by 24, so which is equal to 8a plus or minus, so since both term has a square, so you operate the number, so you will get 16a square over 24. So your x is equal to 8a plus or minus, so you see that 16 is a square of 4, right? So it will be square root of 4a whole square, so square and root, square root gets cancelled, so you have 8a plus or minus 4a over 24. So finally your x is equal to 8a plus 4a over 24, or x is equal to 8a minus 4a over 24. So your x is equal to 8a plus 8 plus 4 is 12, so a over 2, or your x is equals to 8 minus 4 is 4, so a over 6. Now which one is maximum and minimum? For that matter, you need to double differentiate. So we have the first differentiated value here. So now I just have to find the double differentiation. So double differentiation is equal to a square is constant, so differentiate, so you need to differentiate v with respect to x, right? So v double dash is equal to, so this is constant, so it will be 0. Now differentiation of x is 1, so negative 8a will be here. Differentiation of x squared is, so 2 comes here, so 24x. Now when, so since we are to show this one, I'm going to take when x equals to a over 6. So I'll have negative 8a plus 24, and x is replaced by a over 6, 61664. So this is negative 4a. So since a is a dimension, it will be always positive, so positive times negative is negative value, so which means a negative value compared with 0 is greater, so it's maxima. So hence the point here is maximum point. Hence your x equals to a raised to 6 is a maximum point, and we have proved.